Okay, so hello people. So today we'll be solving LeetCode daily question 1463, that is cherry pickup 2. And in this, this is a dynamic programming question. And for that, I would must say that you should check out some articles on 3DDP and how they work. And it's a very famous question of 3DDP. And in this, we'll be given a rows into columns metric called as grid, representing a field of cherries, where grid ij represents the number of cherries in that particular cell. Okay, and apart from this, we'll be having two robots, and robot 1 will be placed at the top left corner, that is 0 0, and robot 2 at the top right corner, that is 0 and columns -1. Okay, and we have to return the maximum number of cherries which both the robots can collect using these for the following rules. And from a following cell, we have to go to the next row, and this is like mandatory thing. Or what we can do is we can go in both the diagonals, or we can just go below. And when any robo passes a cell, it picks up all the cherries and the cell becomes an empty cell. And when both the robots stay in the same cell, let's say, oh yeah, so that means only one can take the cherries. And if both robots move outside the grid, that's not a valid move, and both robots should reach the bottom row in grid. Okay, so these are some of the basic rules which we have to follow. Okay, so firstly, let's create a 3DDP. Let's call it, let's declare it publicly, globally, sorry, int dp, and this is a 3dp, and let's call dp will be equal to new int of size grid dot length and grid 0 dot length, similarly grid 0 dot okay, yeah, grid 0 dot length. Okay, so and now what we'll do, we'll run three for loops at for int I equal to 0, and we'll be canceling out all the invalid moves. Okay, so less than dp dot length y plus plus, and then for int j equal to 0, j less than dpi dot length, and then j plus plus. Then for the kth row, that for int k equal to 0, k less than sorry, k less than dpi j dot length, and then k plus plus, and we'll be setting this particular cell as -1 dpi j k sorry, equal to -1. Okay, and now let's just call the recursive function, that is return maximum max cherries, and this will be taking parameters as our grid, obviously grid, our row, our first robo, and our second robo, that is present at grid 0 dot length -1. Okay, so now let's have a int max cherries function, max cherries, that's taking parameters as int grid, my int row, or let's call it level, and int my robo 1 and int robo 2. Okay, so in that case, firstly let's set the base case that if level is greater than grid dot length, that is we have reached the bottom. Okay, so not, yeah, greater than or equal to grid dot length, that means we have reached the bottommost layer. Okay, or let's say my robo 1 is out of my bounds, so if it is greater than grid 0 dot length, or this might be the case with robo 2 also. Okay, so let's just copy it. Grid 2 greater than grid 2 0 2 dot length, or let's say my robo is out of bound, that is r1 is less than 0, or my r2 is less than 0. So all these are invalid moves, so we have to return 0 in this case. Okay, so now, and also we'll be checking that if my, okay, so we were just filling our dp array with negative ones here. Okay, so we'll be checking that if my dp I j k, okay, not I j k, it should be level r1 and then r2 is not equal to -1, what I have to do, I have to return dp of level r1 and then r2. Okay, so let's initialize a max variable with the minimum value, that is integer dot min underscore value. Okay, so now what we'll do, let's have that for uh, int di is equal to -1, because these like it can go to -1th column, with 0th, like if we go in the next level, then we are having -1 option, same column option, and +1 option. Okay, so my di will be less than or equal to 1, and I'll be checking the di plus plus. Similarly, I'll be having the second option for robot 2, that is for int dj is equal to -1, di less than or equal to 1, and then dj plus plus. Okay, so first let's say my cherry is equal to 0, and then I'll be checking that if both the robots are present at the same place, if r1 is equal to r2, then what I'll do cherry will be equal to grid of level, and I'll be adding it to r1. Okay, you can if you'll add to r2, it might not work. Okay, and then if this is not the case, like let's say they both are present at different indexes, so cherry is equal to grid. In that case, I'll be adding it to I'll be adding both the cases. Okay, r1 plus grid level r2. And what I have to do is, after this I'll be checking the maximum of max is equal to math maximum of current maximum, and my cherry plus my recursive function, that is find max cherries. In that I'll be doing compile passing my grid, and I'll be increasing my level, that is level +1, and my r1 plus my di and my r2 plus dj. Okay, and what I'll be doing, I'll be storing the maximum variable into the my dp array, that is dp level r1 r2 is equal to maximum. Okay, so now let's run it. Okay, it's on line 7. Okay, dp. Okay, mirror error missing return statement. Oh, okay, sorry. Yeah, return dp level r1. So okay, it's giving me tail. I guess there's some issue with the statements, I guess. If my level is greater than or equal to grid dot length, or my r1 goes out of the bound, or my r2 goes out of the bound, or my r1 n goes out of the bound, or my r2 goes out of the bound. Okay, this should not give TLD, by the way. Let me just have a look once again. If both are present at the same level, then I'll be adding it to the r1, or else I'll be doing grid level r1 plus grid level r2, and then I'll be moving this. Okay, I guess it should work. Let me just. Okay, so I found the issue. It was here, and now let's run it. And it gets accepted. Now let's submit it. And it works perfectly fine. Okay, so this was it for today. Thank you for watching.